Okay. So we were writing del pi upon del delta j, that is nothing but this matrix J11, and case is I is not equal to j. So we have assumed that Bij and Gij, this one is dominating this, such that this can be ignored. We have assumed out of two assumptions, Gij is very lesser than Bij, is not it? So this will be 0. And another assumption was the difference of two deltas, delta I minus delta j and vice versa, that is nearly equal to 0. So an angle is 0, so sine of that will be 0. So this is 0. What about this part? This is not equal to 0. Is not it? For very small value of delta I minus delta j, cosine is nearly equal to 1, non-zero. This is non-zero. So overall, this is not equal to 0. So we may write this is not equal to 0. That is J11. This is nothing but, for this case, I is not equal to j. So for this case, we have seen that all elements will be non-zero. Is not it? Now we will check for another set of elements that will be when I is equal to j, like del P1 upon del delta 1, del P2 upon del delta 2 up to del whatever the dimension of that system is, right? Is not it? So this is not equal to 0. So take another case, that will be nothing but I is equal to 0, j. So I is equal to j, it means this is nothing but del delta I, is not it? When I j, it means we may replace j with I, is not it? So this will be del pi upon del delta. Fine. What is pi? Pi is this. So this time variable is delta I. So we will have delta I in all terms except ith term when k is equal to I. When k will be equal to I, so this difference will be, is not it? This is k. So we are having I in all terms except ith term, is not it? So ith term will be independent of delta I, that will be 0, first derivative will be 0. Other terms will be non-zero. So write other terms. So we may write, this is again cosine. So first derivative will be negative of sine, and this is again negative. So positive, right? So directly we may write Vi all terms k equal to 1 to n except k is not equal to I. We may write the magnitude Yik, Vk. This has become now sine, is not it? Theta ik plus delta k minus delta I. Clear? Is it clear to all of you?
Yes, sir.
So except ith term, all terms are having this delta I. And this is cosine, so negative of sine of this, and this is minus, so positive. Is not it? Just take it. So again, we may write it. This is equal to Vi, k equal to 1 to n, k is not equal to I. What it will be? Right, first Vk, and this is Yik. And again, sine A plus this angle. So sine A into cosine of this. Okay, first write Yik sine A into cosine of delta k minus delta I. Sine A into cos B plus cos A into okay sine delta k minus delta I. Put bracket here. This is multiplied with these two terms. So what is Yik sine theta ik? Gik or Bik? Bik. Okay. So write directly Bik. This is Bik. And what about this? Gik. So Gik is very
less than the
nearly equal to 0. So directly we may write this equal to 0, this also equal to 0, is not it?
Yeah.
This is cosine, so nearly equal to 1, this is non-zero, bik is non-zero, so these terms are not equal to 0, is not it? So overall this will not be equal to 0 with the two assumptions which we assumed in the beginning, is not it? Clear to all of you? So we have seen that this is not equal to 0, this is not equal to 0. Now next target is just we will show that this will be equal to 0. What is this? So J12 is del P upon del V. Clear to you?
Yes.
So similarly, using similar procedure, this derivation is already there in Newton-Raphson method of load flow lectures. So from there you can see this and substitute the values of Gik and Gik equal to 0 because we have assumed that is nearly equal to 0. And second assumption is delta K minus delta I. So wherever sine of this is coming out to be
0.
that will be 0 and cosine of that will be nearly equal to 1. So you will see it is task for you and you can see that lecture also where in detail this has been done. For a sample we have just seen this. So similar can be observed for this and this, all these three. So we will see that these two matrices J11 and J22 are non-zero and remaining two are
0.
just see yourself, right? So we have observed that now the Jacobian matrix of Newton-Raphson method is modified, simplified one. Now less calculation will be required, is not it? Earlier we were writing del P is nothing but J11 del delta plus this J12 del V, is not it? Now we are writing del P is nothing but J11 del delta. Del Q, earlier we were writing in Newton-Raphson method of load flow J21 del delta plus J22 del V, is not it? But now we are writing del Q is nothing but J22 del V. That is simplified one. Now this time we have decoupled. So remaining procedures will be same as that of Newton-Raphson method of load flow except this decoupling. That's why this load flow method is known as decoupled load flow method. So another one will be fast decoupled load flow method, which we will see in next class with further assumptions. So there we will see that here again in each iteration we need to evaluate this matrix. Is not it? We have written del P is this. So in each iteration we need to evaluate this matrix. So with further assumption this matrix will be constant and that is known as fast decoupled load method. So there what we will do, we will just evaluate the Jacobian matrix once only. And later on no need to evaluate because that matrix will be constant matrix. So that will be known as fast decoupled load flow method that we will cover in next class. Thank you very much.